I'll just stand here. Right, okay. Thank you everybody for coming to attend the event and especially this session. And you've got to hear me talk now. So, this talk is about implementing a commercial static code analysis tool in a large enterprise. So myself and my partner in crime, Kaveh, will share our experience of implementing such a tool. So quick intro, Kaveh.
Yeah, DevSec consultant. I suppose I have a development background and been doing this for a while. Over to Michael.
Okay, so Michael Mann, independent consultant, works predominantly in the mobile and financial industries. Have a security background, predominantly in ops and infrastructure. Over the last few years, moved into this DevSecOps space, and obviously the founder and organisation of this meetup. So what's this all about? So in our enterprise, our company, we have cool developers, and they produce, apparently, cool code. However, we need to make sure that what they produce, what they code, undergoes a security code analysis. This typically means that we need to provide them this capability, so the whole shift left movement. So what we try to stand up, or what we have actually stood up, is a self-service capability. And that would allow them to factor that into their development pipeline, and automation is the buzzword, so I've stuck it in there. Okay, so the solution, as I said, it's a commercial solution. It's a product called Checkmarx, which some of you may have heard of. I know there are representatives here from the organisation. Checkmarx is based on a Windows stack, so Windows Server was our platform. There is a FIT client as part of this solution. So the FIT client, known as Checkmarx Auditor, can be either deployed on laptops, or if we're allowing a more flexible environment, we've also deployed it within a Citrix environment. I'm just going to quickly go over the solution, the architecture of it. So there are two key components for the Checkmarx solution. What's known as the Checkmarx managers, and also the scan engine servers. So the manager is the brains of the solution. It manages the scheduling, the interactions from systems which are making API calls or plugins, etc., etc. Okay, so the flow, as you probably would expect, we hit a load balancer. The load balancer would either be across data centers or a local load balancer within the data center. So I've kind of simplified that a bit. The traffic will then hit the manager. There are some data persistent that needs to take place as part of the solution. So hence NAS and database elements are part of it. And then once a scan request is received by the manager, it would then pass it on to the relevant scan engine server within the logical file.
Just talk us through the anatomy of that scan request. Does it come through as an HTTP request, and is that effectively what's being balanced across the two managers?
Correct, yes. So the very basic approach would be you'll interact with the manager through the web UI, the browser. You will create what's known as a Checkmarx project. You then point that project to the code repository or upload the code artifact through the UI. That would then be uploaded to the manager. The manager will do some pre-assessment and then work out which scan engine to allocate that job to.
Okay.
Yes, so feel free to ask questions because I like it to be interactive.
And there's the pipeline integration as well, obviously, so you can automate.
Yes. I'm pretty sure we'll touch on that later on. So as part of creating this solution, we've highlighted a few areas worth considering. This is actually quite generic, so it's not Checkmarx specific. So the obvious one is what's the size of the infrastructure that we're going to stand up? How many managers? How many scan engine servers? What is the compute sizing of each of those components as well? Depending on your organization, how many development teams or developers you're actually serving. And that's suitable for this type of solution. So in the large enterprise that where that we've had the pleasure of deploying this solution, figures of 20,000 developers across the world has been quoted, and thousands of business applications. So for us, it was quite challenging, because how do we actually validate those numbers? So as usual, start smallish, and then we'll react to demand. From a technical point of view, the solution needs to address the development languages and frameworks which are being used by the different development teams, and that can range from good old COBOL, maybe Fortran, not sure, to sort of more modern languages and frameworks, so Node, etc., etc. Obviously, a solution can try to cover a lot of this type of technology, but it will never cover everything. And even if it does cover a particular technology, there will always be shortfalls in the solution. Other aspects that we needed to consider is, how do we integrate this solution? So earlier on I just mentioned, well, we could go to the web UI, do that. That's quite manual. So does the solution offer APIs, off-the-shelf plugins? So for example, Jenkins is a popular build server. Is there a checkmarks Jenkins plugin? If there is, how easy it is to deploy, and moving on to adoption. So how easy is the solution to adopt? But once you've stood up such a solution, how do we encourage the development community to actually try out this security testing approach? How does it actually, how can they actually factor it into their pipeline? What is the knock-on effect? Should it be inbound or out of bound in terms of conducting this static code analysis? Lots of questions. Because it's a commercial product, we need to understand what the licensing model is for such a solution. So is it based on number of business applications, developers, combination of both, or some other variable? Now, as part of our journey, when we started earlier this year, around February, I got handed over a bunch of servers. Now, the team had actually went through a lot of governance forums, technical forums, financial forums to get to that stage. And then once they've went through all of that, which probably took about, I don't know, 4 or 5 months, they were only then allowed to ask the IT department to spin up servers. So we don't own the full stack, as it were. So in a lot of talks, you hear people say, well, we can spin this infrastructure up, infrastructure as code, and it's in the cloud, and yeah, we can do all this fancy configuration stuff using Ansible or whatever. Not our story, unfortunately. This was kind of like the real world experience for us. We got handed over servers, which obviously had to be predefined, architected. So obviously the architects had discussions with the vendor to try and size up roughly what the first instance would look like. Even once we had the servers, that was no good, because we had to raise numerous requests. So I needed to create a different login to gain access to the server. We needed to provision service accounts, because obviously I didn't want the solution to run under my user ID. And once I had my user account, I had to sort of kind of pair that up to gain access to the server. So that was another request. So lots of prep work. And other things such as creating DNS aliases, requesting NAS share storage as well. So these areas are things out of our control, but things that we had to work through before we had the basic pieces to start technically implementing such a solution. I had the pleasure of creating the first instance, and I did this manually. So I double clicked on the installer, this GUI came up, and it was kind of select the options, go next, next, next. That was all fine. And then that was the basic install. But as I started to configure up the solution, I had to sort of start the various services. Now, the solution I originally had about a dozen servers, and sort of right-clicking for each Windows services on each server to go through the configuration became quite a ball ache. So the first very noddy script I knocked out was basically a stop script, start script, and restart script, and that made me happy. I'm a simple person. Now, once we stood up the first instance, we recognised that, well, don't want to go through that again. So we started to code up the implementation of that. So I started this journey. I'm a very optimistic person. So I basically, when I was doing it manually, I documented everything as a good boy. And basically I translated that, my build notes, into code, and that's what we call the happy path. And then Kaveh came along, started to work with me, and then we quickly worked out that it's not always happy. So the point that Aubrey made around it takes more effort and time to do the testing, to find the exceptions, etc. That did consume a lot of time for us, but it was a good experience. Another point I wish to make is when I did it manually and double-clicked on installer, this GUI thing came up, but that same installer I couldn't use as part of the script, because if I did call that installer, this GUI thing would just come up. So there was another installer known as the silent installer, which I had to obtain from the vendor, and that was kind of like going from one extreme where you'll get this GUI to another extreme. When you hit the silent installer, it'll just disappear. And literally, what do I do next? How do I know it's finished, etc., etc. So these were all sort of technical steps we had to sort of understand and capture in our code. Modifying configuration files, that was, again, I took the happy path. It was literally find this string of text, replace it with whatever I needed. We quickly moved away from that approach. Secrets management, so another hot topic. So I need to gain access to the server. Once I've installed the checkmarks application, I need to interact with it to do certain configurations. So, for example, we've got the manager, we've got the engine, but I need to tell the manager there's an engine. So we had to interact with the checkmarks solution via its API. Obviously, that requires authentication. So how do we do this apart from hard coding our own credentials in the deployment scripts? And kind of on that note, when we did run our deployment scripts locally on the server, let's say on the scan engine server, and it got to the stage where it needed to interact with the manager, we needed to remote execute some certain codes. So that was another, not hurdle, but another feature that we needed to build in. And the last 2 points is where Kaveh actually really saved me, or saved us, was to factor in the different exceptions and also make our deployment code stateful. Very exciting stuff.
Great. Well, so like Michael said, I mean, we pretty much are trying to roll out an enterprise service. The user of the enterprise service are internal, but still we have to address the concerns that come with that. So if you kind of break down the different steps of trying to roll out such a system, you first do the initial deployment where you try to figure out exactly what it is that you want to do, what are the requirements that you need to address in terms of scaling and sizing, and what kind of information you need to modify and what configuration files you need to sort out. So as part of that, I mean, if you have a look at the manual deployment steps that Michael, I don't expect you to read this, but you know, these sort of requirements, some of them came from trying to scale out the product. Other ones were to adhere to the requirements of you know, the secret management or other requirements, security management that came from the enterprise. And we basically also had to engage the vendor to understand what kind of changes we needed to make, because when you actually do the basic installation, I mean, fundamentally these installers would just put the software there, and then the configuration to make it work, you know, at scale, a resilient solution and so on, needs to be something that you know, you need to configure for your specific environment and your use case. If you look at it from a maintenance and upgrade cycle, so this is a security product, so the rule packs are changing. the feature sets are changing, and you want to basically try and keep up to scratch with that as much as possible, because that's where you get the better value for money and more secure code. So if you think the vendor does quite a few minor point releases every year, and within that there are a bunch of hot fixes that you may or may not want to deploy. So and if you think in terms of the number of servers and so on that you need to apply these upgrades to, then it becomes quite substantial effort. Of course, even though the vendors tested things, you still want to test things out within your enterprise environment, from the interactions that the system will have with your single sign-on. You want to have like a test Jenkins scan that sort of does a smoke test to make sure that it's working. You've relied on some APIs from the previous version, and you want to make sure that the new release hasn't changed the way those things work. Similarly, you need to also think about packaging within the enterprise the thick clients and sort of interacting with the different teams to roll out. So again, we're very much not in the DevOps world still, and so there's a whole bunch of interactions and communication that we need to do with other teams within the enterprise to get things done. So from again, I mentioned that there are multiple servers that we need to perform this upgrade on, and also when you think of the production rollout, there are other activities like you want to, once you've even verified things in the UAT environment for production, you want to take a snapshot of the database, you want to shut down the servers in a controlled way through the API that the vendor provides, and then you also want to bring up like a one checkmarks manager and one checkmarks scan engine, upgrade them, verify that it's working, and if it didn't, then you need to roll this back and do that. So in terms of what you actually need to do, there's a fair bit of activity that needs to happen as part of the maintenance and upgrade. And again, Michael mentioned that there is quite a large development community, and we're still fairly early in getting the entire enterprise to adopt the solution. And so thinking ahead, we need to think about how we scale and expand the service to be able to deal with the business demand. So we've already kind of doubled the number of engine servers that perform the scanning as part of this sort of fairly early stage adoption within the system. You'll have teams that will have specific requirements. They don't want to wait to be in the same queue with their scans, waiting in the same queue as other people. You want to be able to roll this out to cloud environments, which should be hopefully easier than doing it inside the enterprise. And also you may want to sort of stand up brand new instances of this solution for highly regulated countries where code cannot leave one location and needs to stay in one geographical location. So if you think back to sort of the steps that we need to effectively follow in order to roll out or roll back or upgrade these things, then and the number of servers that we need to do this on, you sort of very quickly, especially if you need to do this under duress, you can immediately kind of see how it might kind of drive you a little crazy. So all of this is a kind of obvious case for automation. So obviously then if you've automated this process, then it becomes reliable and repeatable. Removing the human element, the error element, allows us to do scaling and sizing more rapidly and roll things out. And from sort of Michael and I's perspective and the enterprise, we're consultants, so we won't be around. So it's important for it to be self-documenting and easy for us to hand this over to people who will maintain the system moving forward. I think one of the things that we haven't really discussed basically in this thing is the sort of BAU aspect of it, as how people will carry on and sort of run the system on a day-to-day basis, and that's basically the support team, and that's a slightly different thing to what we're discussing here. So yeah, so automation is an important part. Sorry, just back to Jack Nicholson. When we came to try to automate this, we needed to make some decisions. So we're still far away from being able to use the So to sort of show you a little bit of how it will work, we have a little test script that you can run, and so the first step is pretty much to check the prerequisites of your environment. So this, you may want to check that the installer is being copied correctly, the checksum is correct, the version of Windows that you're trying to install on is correct, that iOS is installed. So here in this sort of noddy example, we see that one of our prerequisite checks has failed because that particular directory doesn't exist. Now, obviously, that's something that we can fix programmatically, but there are situations where you're not able to recover from these kind of things. So here our script has ended. So what we do is we'll try to do a manual resolution of the problem. In this case, I'll just make the directory. And now what we can do is we can then rerun our script and try to see what happens. So our little script will then, and this is sort of a boilerplate that we can apply to all the different scripts that we've written, so that it checks to see, oh, great, I can see that you've run this test before, this script before. Do you want to resume? And at this point, it basically loads up the variables that allow us to, and so it's quite common for you to have to pass variables from one step to the other. You may, for example, create a certificate. You want to take the thumbnail and then put that in a configuration file. You may want to take that, the public certificate, and then register it with some cert store. So there are variables that you want to pass from one step to the other. So it's not that they're completely discrete. So we're able to save some of these variables, which follow a particular naming pattern. And once you're actually ready, then you can then pretty much resume where the previous step failure occurred. So, and in this case, then here we can see that all the prerequisite checks have now completed. It progresses to step 2, does some additional tests, and fundamentally then your script will complete. So I mean this the things that we had to do here was a combination of rolling our own kind of mini test scripts for our PowerShell, and the ability to be able to sort of remember and resume these steps as we go. And I mean the stuff that we've done kind of follows some of the standard practices that you'd see. So you'd have like an environment, PowerShell environment scripts that capture the inventory of servers that you have and some basic variables that you want to do. So you can actually point your scripts at the different environments when you want to run them. Oops, sorry. You've got sort of Michael's initial admin scripts, the build scripts that capture the high-level activities of deploying and upgrading and uninstalling. We've got our tests, because testing is good, as always pointed out earlier. So we want to check that our stuff is actually working before we try to roll it out. And then we have some modules that capture some of the common things that we need to do as part of the rollouts that we do. So here's kind of a basic example of our Uat environment script. You have the variables that capture the users that you want to, for example, deploy service app, and then you have a whole bunch of the inventory of the services, whether they're checkmarks manager servers or checkmarks engines that you want to repeatedly apply the upgrades or downgrades or whatever it is that you want to do. We've got the ability to, you want to point your scripts at a particular environment when you're testing them. I mean, this stuff is fairly straightforward. And then in this case, what you're saying is we've wrapped one of the checkmarks, a bunch of checkmarks APIs for authenticating against the checkmarks manager, and the ability to query the number of engine servers, suspend them, start them up, or remove them from that. And this sort of we wanted to test these because as checkmarks upgrade their product, the API might change, and that would break everything that we kind of rely on. So again, the ability to test is pretty key. So the sort of bare bones skeleton of our scripts is basically you have these, and when we were putting this together, we wanted to not make it into like an object-oriented program that you need to have very specialized knowledge to extend. We just wanted to have something that's straightforward for somebody with some fairly, minimal technical background to be able to look, extend, and repeat if they need to do that. So we have these little scriptlets that capture the steps that you want to do. So this is going back to the example that I showed you in terms of verifying a prerequisites, pretend installing a checkmarks engine, and then configuring it. And then you basically put the order of those scripts here. That's the order that we're going to execute them. And you sort of specify the pattern of variables that you want to save between steps. So if you call anything, if your scriptlets could declare a variable with cx_, then that's what we're going to save in the file, so that the resumption will pick it up where it left off. And this bit basically checks to see if you've run the script before. If not, then it'll invoke it from the step that you previously completed. So here's a kind of a brief introduction to one of those steps. So you have, obviously you import the modules that you want. These are the different steps that you actually, the scriptlets that you want to run. So it's a sort of like a playbook of what you want to do. You have the try and catch because you don't know what will happen in the actual body of what you're doing in case something unexpected happens. And then you have the actual body of carrying out and doing a particular step, like checking prerequisites or installing the engine through the silent installer and verifying that the registry keys that you expect after a successful installation are there. So here we have a whole bunch of tests which check a particular condition. So you'll have the condition that you expect to be true, and the return the test will print out and log its progress as you continue. You have the variables that you want to pass between steps, defined using the pattern that you've previously declared. And then finally you want to do a check to see, for example, if all of the steps before completed, in which case you can progress on to the next step, or if not, then you want to stop. So here, this is the one that does the meat of the work. So you tell it what prefix variable you want to save. Variables that have this particular pattern will be saved. And then you have the ability to, through the test cases, to increment an error count so that you can do multiple tests and then fail at the end, or selectively fail as soon as that particular test fails. And that's pretty much what we did. And so there's some other examples about how we go about saving these variables. So PowerShell is pretty powerful in terms of allowing you to query the variables in scope, and then later on sticking them out into a file and being able to restore them. This is an example of the actual steps that we needed to follow to deploy a checkmarks engine server from scratch. So we checked the prerequisites, we backed up the installation directory, we ran through the checkmarks silent installer. We validated that it actually installed correctly. Generates SSL certs, register them with the checkmarks managers, modify the configurations through XPath expressions to find specific things that we needed to change, and pretty much a few other things that made our life simpler. And we've got a whole bunch of modules that capture things that we do regularly. To verify, and it's common between the different scripts that we've written to be able to stop and start services, even if they don't live or die gracefully, and to verify that the installation is actually working. So some things are missing.
Yes, so nothing's perfect. We're still on this journey, although from a project management point of view, we've baselined the script. We talked about, I mentioned secrets management, so talked about the OS authentication against the application itself. When you're creating a new certificate, how do we, defining what the passphrase is to protect the private key, etc. So what we did was basically get our scripts to prompt us to enter those values. not slick, but it was the easy option. Now, as part of that, I've been speaking to different teams within the organisation. So there's a technical team within a business, so vertical. They have a similar situation, and they're trying to introduce a particular solution into the enterprise. I spoke to one of the global centralized tooling team as well, and again they were kind of on this journey as well. So I formed a triad in this organisation to try and formally introduce a secret management solution for the enterprise. You may think that, well, that should be in place already, but it's a large enterprise. It's circa 200 years old. It's kind of set in its way, and this new approach of development, etc., and the topic of secret management is relatively new. I mean, they are used in other commercial products such as CyberArk, but I won't go there. PowerShell, so we haven't gone through the whole process of signing the module so that it can be ran on each of the servers, so we have to go through that enablement each time. We have a number of different files with different variables, etc. It's easy-ish for us to sort of make and change if we were doing it, because we wrote the scripts, we did the coding, but it's not. We think it could be improved if we were to give it to other people. So that's another backlog item that we're going to address. And also at the moment, as I mentioned earlier, the scripts are kind of ran locally. So if I need to stand up a new checkmark scan engine server, I log on to that box, make sure the artifacts are there, the scripts are there, and then run it, and it builds it on that server. Again, baby steps, that works for us at this point in time, but ideally what we want to do is have, do it from a laptop or from some sort of management server, and then say, right, these are the 20 servers we need to stand up, these are the managers, these are scan engines, pass in those variables and say, sorry? Yep, and then away you go. So, so these are some of the missing pieces in our development, which we will be addressing.
Early on you mentioned the fact that you need to discover where things are, so are you committed to also add at some point service discovery to this?
That's something that we've talked about, but we're not quite there yet. Yes, it'd be an area we would need to look at. Reporting metrics. So it's great that the business wants developers to develop business functionalities, business applications. It's great that security wants to do some security checks on that code. But what's our return on investment? What are sort of key indicators from an ops point of view, from a management point of view? That's important to give that warm, fuzzy feeling that it's worth spending X amount on this commercial product. So we started to look at this over the course of the last month, a few weeks actually. So some of the points that's relevant at this point in time. And so as part of this presentation, we quickly used Elk and knocked up an example dashboard. So top left, there's a queuing system within the solution. So jobs come in, the manager does the scheduling, etc. But there will be a point in time where there's more coming in than that's going out. So we've got a gauge to indicate what's in the queue. Obviously the UI provides us that, but if we're also interested in other elements of the solution, then the UI may not provide us that information quite readily.
So you want an ops dashboard that shows you what's really happening from a running the service perspective, the memory usage on the servers, all the stuff that you'd expect, and then obviously then is the KPI metrics that the users or that the business might be interested in, and then the other KPI metrics that developer managers might be interested in to see how their specific team is doing with respect to the security that this particular tool is providing. And And I think this is kind of like a template for hopefully the other tooling that's used within the.
What percentage of this code base have you scanned?
So good question. So our early adoption for the solution began in May. Obviously there wasn't a lot of raw data for us to crunch through, so we took August, so that was a good 3-4 months in. So we started to crunch through numbers in August. So in August alone, so summer period, people on holiday and good things like that, not everybody onboarded within this enterprise. We scanned 1 billion lines of code just in August. So that's a big number to me. And obviously we're still trying to grow or encourage the adoption of this solution.
Are you running into the resistance of we don't want to know?
Don't want to know
how many defects we have in our code. So
no, so the purpose of this talk is not.
No, probably never.
So the purpose of this talk is not so much about what's our remediation approach for findings or determining findings are actually vulnerabilities, etc. That piece of work, that governance piece of work, is being worked at from our project's point of view. The purpose of this talk is really just to share our experience of implementing a commercial product in a large organisation and some of the challenges we faced.
In terms of time to scan, so how do you relate the time to scan the X amount of lines of code?
So the vendor will quote a range. So in this particular case, and correct me if I'm wrong, vendors, it's between 100,000 and 250,000 lines of code per hour. So it depends on the language and all that sort of good stuff. That is of interest for us. So we have crunched through some of the raw data to get a feel for that, because depending on the business applications architecture, they may be quite modern and use microservices, so therefore the lines of code that they will need to submit or change is quite small, so let's say a few thousand, and obviously that will go through the system pretty quickly, maybe less than a minute, maybe a couple of minutes, but we do get some numpties that actually send through 10 million lines of code, and then they call us and say, it's not done yet. It's like, really? So their development approach is obviously somewhat different, and so there's an educational process that we need to go through and work with them to understand that, to tell them that this isn't magic, and why are you actually submitting 10 million lines of code? Are you really making that many changes in such a large code base? Could you not split it up in any way? Simple things like by language. So I'm assuming your development isn't just using a single language, as an example. So there's all these different options that we need to touch base with, challenging teams when they start adopting this.
But often you find, in this one particular case that we looked at, they were scanning the Dojo framework 3 times. So that bundle that they were including had that, but also from a scaling perspective, we have specific scan engines that are for larger code bases, so that they have more resources and CPUs, and try to address that. But still, that's not going to be any time quick. It's not going to give the results necessarily very quickly, and we need to also check with the vendors to see whether there is a good case for scanning entire code bases that may not necessarily be directly related with each other, versus having those splitted, the code base split out, and having scanning the individual microservices, and the boundaries are fairly clear. You can look at that, and then it doesn't matter if you now scan that with some other component that's using the microservices, because you know where that boundary is anyway.
You end up integrating with a CI/CD pipeline again, or there's still work to do?
No, that's integrated with Jenkins. So there's plugins and so on. So it's the submission. I think actually one of the metrics that you see on the right shows you that the majority of the
scans are
actually kicked off through Jenkins. So that's that pie chart over there. So you see the difference. So there's the ad hoc way of using IDE plugins, or the interface, the UI interface, or through Jenkins. So I think, again, in this enterprise, one of the challenges that we have is that there are central teams that manage the pipeline as a service, and trying to get things into that is difficult, and trying to get them to build flexibility into how to control the actual scanning is they try to dumb things down, and it creates problems, so you can't do it.
Why do you scan so late?
Late as in...
So you scan in the pipeline, so your system slice is relatively small, which means that there's a few people. I would expect system and pipeline I would expect system to be bigger than pipeline, because it's the first chance to scan the code, right? You don't want to put shit code in the code base, you want to get to it early. But you guys are doing it
so there are IDE plugins, is that what you mean? Where people are scanning their code as they're developing it? Or?
Yeah, you're saying that Jenkins is the majority, whereas I would expect everything but Jenkins to be the majority.
So it comes back down to sort of culture and terminology. Lots of people use the words, so they like the words pipeline, automation, etc. So when that kind of filters down to techies, they say, oh right, we need to put it there. Whereas what, in reality, for such a solution, there are different ways of consuming it. So the IDE plugin ideally will be the first port of call to kick off the scan. Once you're happy that the security threshold hasn't been exceeded there, then obviously do the merge, etc. So it shouldn't be the first scan, but it's an educational piece that we're trying to work through with the development community to say, look, there are other options here. When your management tells you must factor it into your pipeline, it doesn't necessarily just mean when you kick off your build in Jenkins, then configure check marks to do the scan. And that's probably where some of the misunderstanding has happened with the team that's submitting 10 million lines of code.
But I think that goes around having the assurance program in place and telling people when to do things and trying to encourage them to do that. I mean, within these enterprises, there are also challenges in trying to actually get software onto people's machines, so not all developers don't have admin rights. So it's just, in fact, trying to get something onto your machine requires you to raise requests, and so actually there are obstacles that we've placed in between the developers and the path that we want them to follow. But that process piece, again, is something that's kind of out of really our control. We're just trying to enable them to use that. But and the other challenge with some of the tooling is that if you're trying to scan from your IDE, depending on what you're scanning, it'll take a while, and that might, I think in this case, checkmarks doesn't actually lock up your machine, but it still takes a while depending on what you're scanning, and it ends up sometimes being easier to go back to whatever you've actually checked in and scanned through the pipeline to review the results. We in fact don't know how many people are actually looking at the results in really accurate.
Well, quickly moving on, there was another question. Go on, Chris.
Once you've got all your results there, and so you've got 10 teams who are holding scanning the code, I know in the enterprise there's a big emphasis on providing evidence, to the relevant kind of security bodies.
Yep.
And we thought about providing the capability to, I guess, at first, just provide a report that shows that you're fixing your issues, you don't have any, and then eventually integrating with Jenkins in the other side, so that before you're allowed to release to production, it kind of queries, you provide an API that it queries to say, yeah, this team don't have any major issues. We thought about how to automate that provision of evidence.
So that's still being worked through. So it's great having this scanning capability, and it's also wonderful that they're using it earlier on. But then, is each submission actually a potential for code promoting it into production? Ideally, yes, but in reality, probably in our organisation, not. So therefore, one of the challenges that we need to work through is identifying which project, which scan, and which associated code repo that they're using is actually the release candidate that they've said will be promoted into production.
And I think interestingly, the commercials also have a play in this, because if the licensing model is per project, well, you'd think, you can have a different project for every branch or for every release that you're doing. But then if that then begins to have an impact on how much you have to pay for the product, because now you've you've used up more licenses. So there's some things that we need to work out around the commercials, unless it becomes all you can eat, that have an impact on what happens. I think the Jenkins plugins actually within Checkmarks have a way of you can provide these criteria where it will actually break the build, except that when the scan takes X number of hours, what does that mean? Is anyone ever going to wait for that thing to build, other than, let's say, for production release things?
Because ideally you've got one code commit is one build, is one release, is one deployment, but in reality it's probably 100 code commits. You can't fit every build, right, because the team just won't use it. So then you've got to kind of aggregate them all together and somehow make a decision on whether it's
which is somehow counterintuitive to the way that you want people to work in trying to fit that.
So it's the maturity of the development community in this enterprise varies from nothing to quite good. So for us to try and address all of that, it's going to take some time.
How does your infrastructure deployment model looks like? Is there multiple region, multiple scanning region?
So at the moment, centralized instance, but we, as part of having the deployment scripts capability, we're allowing the ability to stand up different instances or dedicated instances for teams or a business unit, etc.
So when you did the product procurement for this, how big a factor was development experience in this DX? Did that weigh in at all? Did you take this to developers and do the market scan and then say these are the solutions? What was the experience? Because obviously, if you're saying it's incredibly heavy on the local machine.
No, it's not. No. So unlike other static code analysis, when you do kick off a scan, it doesn't consume all your development workstations resources.
Happening remotely, effectively, in this instance.
But probably speed is probably the preventative thing, right? So you want speed in checking. If you're hitting a pre-push hook and then you're doing your checks, your code analysis, right? You're going to want that to be quick rather than who cares about resources. It's the speed at that point. Was that weighed in?
Yes, I mean performance was an actual. So the proof of concept was conducted last year, and engagements with a sample of development teams was made. We did try to walk through the whole scenario of usage, performance, integration. What does the results look like? Does it look good to you as a developer? Does it look good to you as Mr. Security or Mrs. Security? We tried to go through that whole process before and produce the evidence before we could go through different governance forums to formally introduce this product into the organisation. Not saying that exercise was perfect. Some aspects were clearly missing because of, it wasn't a priority for those nominated teams to work with us as part of that selection procedure. So we had to make certain assumptions, etc. Obviously, speaking to other customers as well from the vendor was useful, but they wouldn't give us a shitty customer to speak to, would they?
but I think the other question is, I mean, in DevOps, speed is the thing that's the metric that seems to come up the most, and especially around the kind of static analysis that Checkmarks does and similar tools. This is a time and processor and memory intensive process, and so you can get quick results, but there will not be good results. So I think there's got to be another solution.
May not be good results.
No, there probably won't be good results. I mean, that's the truth of it. I think by the time it tries to go through that, you're right. But I mean, I think by the time it tries to go through the different data flows and the paths, it is time consuming, and it's not going to be at the blink of a button, a blink of an eye. And so I think there's got to be some way of trying to put these things together and understand that it may be that you roll out and then you look at the results and then you switch off the feature that you've rolled out because you've realized you've rolled out something that's insecure, or quick prioritize the fixing of that issue. I don't think there are at present anyway solutions that are quick enough to give you that good result set quickly enough for you to be able to just run through your normal development pipeline and not worry about that impacting, if you're going to wait for the results, impact your throughput.
So this is slightly out of scope of the talk, but clearly there's a range of security testing that can be factored in. Static code analysis is just one of them. So it may or may not work for your organizations. You may have strong views about static code analysis being it's too heavy on false positives, etc. Tuning takes forever, so therefore onboarding a business application, I don't want to go through that learning curve. So I'm not going to do static code analysis, whereas it may be the opposite for certain situations. So pros and cons. I'm not here to defend static code analysis. I'm just here to. He is. I just want.
So just quickly, was you complemented with DAST in this case? Were you effectively looking at dynamic analysis, or if you're not able to do source to sync, that's what you're saying, right? You're able to do source to sync basically within the context of DevOps, which I would agree with. So what tends to happen in those cases that gets complemented with dynamic.
Yeah, so I think there's a whole bunch of tooling there's the standard dynamic analysis that's done, and now that could be manual penetration testing or just pointing a configured DAST sort of bot at your application where it just throws payloads at it. The other solution that seems to be working well and has, at least if I'm not mistaken, fairly good developer feedback is this sort of IAST where it relies on it fits perfectly with DevOps, because if you've got a whole bunch of tests that really exercise your application, this thing instruments it and then tries to follow the flow as the tests go through and feed data through your application. So there are definitely checks and balances in place. I personally think that static analysis has its place and it should be one of the tests that you do, but it's definitely not the only one, and it has its specific problems because of if you're trying to get good quality results, it will take time, unfortunately, at present. So
as a follow-up question to that, so did you integrate this with a defect tracking system? So if you effectively running multiple tests, are you looking at prioritizing and deduping results in any way before they're fed back into tracking system of some sort?
Not at this point in time. During one of many proofs of concepts ran last year, that aspect was being looked at. But there is another stream of work within the enterprise trying to aggregate all the security testing results for a particular business app and then sort of kind of normalize that as deduping, etc., to say, right, the security profile of this business application for this release is this.
But I think also with a lot of these tests, to take a potential vulnerability that a tool has identified, you don't want to make each one of those necessarily a defect, because the defect is where do you actually fix it, and that's the thing that you want to resolve. And these are symptoms of that one particular remediation that you need to put in place. You'll have probably 10 different vulnerabilities that will get, or even more, that one particular fix will. So it's I think there's got to be some human interaction where you take a bunch of them, figure out where the fix is, and put that in place, and then tie these ones to that particular defect, these vulnerabilities. I think that's probably the. Yeah.
So the term I like to use is findings, because until they're proven to be real findings and therefore a vulnerability or false positive, it's just a finding.
So maybe I think we're almost time's up.
We are almost done. So just quickly flicking through lessons learned on-premise cloud idiot. So you may have picked up that.
My fault. Yeah.
You may have picked up that our solution was an on-prem solution. Our hands were very much tied. Some of the aspects that we felt was useful for us as a delivery team was feedback. So traditional waterfall approach, you had the different nominated roles, architects, tech lead, operations, and that kind of just flows down one way. That doesn't work, as we all know. Sometimes we fell into that mode, but we fortunately for the team that I'm in, there is actually good feedback amongst the 3 different pillars. So we did. I believe we don't have any silos, and some of the interesting design topics that created a number of heated discussions within our teams are listed there. conscious of time, so I can't go into too much detail, but if you want to have a catch up afterwards, then happy to discuss. I've created a GitHub repo to capture these slides and some of the templates that we've shown, and there's a link to the vendor's documentation if you're so keen to have a look. And that's us. Thank you.